fun problem here that I've seen proved in various ways all over the place. I do want to tell you though, for n equals 1, trivially this is equal to 1 squared. So we're talking for n greater than 1. So this is there's always these kind of things with 0 and 1 going on. Now for n equals 2, you would have this, and that's certainly not equal to any kind of perfect square, right? We'll say, what do you want to call it, k? It's not equal to k squared for any value of k. And then 111 actually gets sort of close. Okay, but it's also not equal to k squared. It's sort of close because 11 squared is 121, right? But it looks like we have numerical evidence that if you string a bunch of ones together, it's never going to be a perfect square, although this is scant evidence actually. Okay, so now I'm going to write down what n1s actually means. You can think of the digit 1 as being in front of each of these powers of 10. I made it like this for a reason. You can see there's actually n objects right here, right? This is n minus 1, then you have the 1 here. So there's actually there's n1s right here. Okay, now a result that I've proved in, well, not quite, but I've shown that if 2 fully divides a number, that number can't be written as the difference of 2 squares. And 2 divides this expression right here. It doesn't divide n once, but it divides all these powers of 10. Now that's not too hard to see because right here, the best we can do is 2 times 5, right? So there's only, now the previous term would be what? 2 times 50, right? For 100, right? So you can see that there are, this is actually equal to 2 squared times 25, right? 2 squared dot 25. But what I'm trying to get at, folks, is since you can only take 1, 2 out of all of these powers of 10s, this parenthetical expression is 2 times some odd number. Okay, I'll just put odd here. Okay, it's 2 times some odd number. And this number has to be odd. If it were even, then you would have more, it wouldn't divide this because there's only 1, 2 right here, right? So this is pretty clear. So 2 fully divides it. No higher power of 2 is what this means. No high power of 2 can divide this. That's what the double vertical bars mean. Okay, now n1s minus 1, right? Okay, is equal to this object that we're interested in. So we know that 2 divides n1s minus 1 fully. And that means that no higher powers of 2, 4 doesn't, 8 doesn't, 16 doesn't, no higher powers of 2 other than 2 divides our object of interest here, or close to our object of interest. Okay? So now if we want to write this as a perfect square, if we want to write n minus 1 n1s as a perfect square, this result would follow, right? Now notice this is the difference of 2 squares. So we know that, and I'll just say, I hate to say this, without loss of generality, actually there's no way around it, but we can go ahead and assume that k plus 1 is even. We could also assume that k minus 1 is even. It doesn't make any difference. Okay, so we'll assume k plus 1 is equal to, let's say, 2m. Okay, and again, same argument. You'll see the same thing would work if we rearrange this. So if k minus 1 has to be odd by our earlier arguments here, and let's use 2m sub 1 plus 1. I always run out constant. It seems like when I'm trying to do a detailed proof. Okay, now notice what happens when you add these two equations. You get 2k. And this is what makes the proof relatively elementary. I didn't have to appeal to anything too deep. We get 2k is equal to, now if you add this side, you get 2 times m plus m sub 1 plus 1, right? And of course, this is patently, this is impossible, right? Impossible. Right, folks? So what I'm saying is that, what we're saying is that this expression can't happen. If this expression were true based on previous arguments and hand waving, we would get this impossibility here. Okay, we would get an even number equals to an odd number, right? If you did the work here. And again, y'all do notice that if you had assigned k minus 1 to 2m and k plus 1 to 2m sub 1 plus 1, same kind of thing would have happened, right? So this statement is impossible. So that means that also our n1s, and I couldn't get myself to make up another name for n1, so hopefully this explicit rendering is something you guys, n1s is not equal to k squared. It can't happen. And this is a general proof. I don't think I left much out here. n1s cannot equal to k squared because of this impossibility. This can equal to this, and so you can add and subtract to inequalities too, right? So this concludes our proof, folks, and I'll put QED. And again, I don't know what you guys think about it, but I think every time I see somebody else's proof, I always think my way's easier. It's because everybody understands their own way. There's no disrespect going on there. But I think there's not much happening here. This is the big truth right here. Only 2 divides this entire sum of tens, powers of 10. No higher power of 2 can divide it. And you see, that's what leads to this contradiction ultimately, because only one of these factors can be even. The other one can't be even. Otherwise, you would have a higher power of 2 dividing it, right? So in a sense, it's super simple proof, super simple proof. So anyway, I think that gets the job done. Thanks for viewing.